Hi, welcome to Algebra 2. We will continue with Lesson 2-1, Example 2, Determine key features of a quadratic function. So what are the key features of quadratic function f of x equals 2 times parentheses x minus 3 squared plus 4? So first of all, we need to remember that the parent function of a quadratic function is f of x equals x squared. So any transformation that happens to the entire function will be here or here because your x squared is your parent function. So if anything happens to x, like some a times x, that means you have ax squared. And for example, if you have x plus k, then that means you have x plus k, all of that parenthesized, square. Okay, so this is just an example to see how vertical and horizontal translations and transformations were different. This was in lesson 1-2. So if you need a reminder, please go through lesson 1-2 again in order to be familiarize yourself with transformations of a function. So knowing that, we can easily find that the graph from the parent function is going to be vertically stretched by a factor of 2, and it's going to translate up 4 units and to the right 3 units. Because for x, if you subtract your h, then it means you're adding. So if your h is positive, so in this case, your h is positive because your function for transformation of the horizontal translation would be x minus h. So in this case, you will go right 3 units. Okay, so you have to first see that your vertical or horizontal transformation or stretch or compression are positive or negative. So if you're multiplying by a factor of positive, then you're not doing any reflection. Again, negative number for your transformation of a function would represent reflection. So if it's a positive value, then the graph will look, the shape will look the same as the parent function, and it will, like, the direction of the shape will be the same as the parent function. So your parent function x squared looks like this, right? And it's pointing upwards, it's facing upwards. So because we have a stretch by positive 2, it means the graph still opens upward, and it's also vertically stretched. Okay, so it's important to know where it opens and how it's stretched or compressed by 2 here. And you know that the range is greater than or equal to 4 because from your original function, you moved up 4 and you moved right 3. So your vertex starts right here, 3 comma 4. And that means that's your minimum point of your quadratic function, right? So the vertex would always be your h and k here. So if you see the vertex form of quadratic function, it's really easy to see the vertex, and you can see the shape. You can imagine the shape even before you actually graph it. Okay, there are no restrictions on the value of x, so it's all going to be real numbers. So make sure you talk about the range and domain when you talk about key features, and the direction of the graph, like where does it open. So especially for quadratics, we have to point out where it opens. Does it open upward or downward? Also, why don't they open leftward or rightward? Well, they do actually, but they're not considered function if they open left or right. you know these points are gonna fail the vertical line test, right? So by the definition of function, it fails to be a function because one input has more than one output, and that is not a function. Okay, so you need to talk about the direction where it's opening. Is it opening upward or downward? Basically, you have a 50-50 chance, but you have to look at your the value of A here. And is it vertically stretched or vertically compressed, or is it horizontally stretched or compressed? But in our vertex form, you will only see vertical stretch or compressed. So make a note on that. If it's always outside the parentheses, you will find that it is a vertical stretch or compression. Okay. Yeah, let's try number 2. Let's see if you can identify the vertex, axis of symmetry, minimum or maximum. We didn't really talk about minimum and maximum in example 2 by word, but I did point out that your vertex is the minimum here, right? So here you need to figure out if your vertex is minimum or maximum and point that out. Write the domain and range of the function. Okay, so this is already in vertex form, so it shouldn't be too hard. Try comparing your function with your parent function. Okay, so pause the video and come back when you're ready for answers. All right, are you ready? Okay, let's see if you got it correct. So first of all, your function is in your vertex form of the function. We looked at example 1, right? Is a times parentheses x minus h squared plus k. So please remember that your vertex form is a times x minus h squared plus k. And this is already in the vertex form. So you know that a is -1. So identify all the important information. H is -4 because it's x plus 4. In order to be x, to add 4 from x, you have to have a -k here, right? And your k is going to be -5. Okay, so looking at that, you already know the vertex, which is going to be h comma k. Your vertex is -4 comma 5. Okay, and then axis of symmetry. So the axis of symmetry, for example, 2 right here is x equals 3. So your axis of symmetry is basically going to be the middle line where the graph reflects, and it's always going to be x equals something, because if it's y equals something, your axis of symmetry is horizontal, and that means your function is not a function. So unless you have a quadratic function that looks like these, which are not functions, and if you see all the actual functions for quadratic functions, you'll see that your axis of symmetry will equal to x equals h. Okay, because your vertex is always on your axis of symmetry. So the x value of your vertex would be h. So axis of symmetry for try number 2 will be -4. X equals -4. So you have to write the whole equation, x equals -4. All right, and is this a minimum or a maximum? Because the graph opens downward, right? Because your AA is negative. And so you have a maximum. And the maximum is equal to your vertex, -4 comma -5, but your maximum value would be y is equal to -5, and that's the maximum your y value is going to get. Okay, and let's see, what did we not do? Domain and range. This is the first part of your answer, so I'm going to make a box around it. Domain is all real numbers, so you can write a big capital R with two lines here to represent all of our numbers, or you can put your interval notation, or you can use the set notation where x will be anything from negative infinity to positive infinity. Okay, and then range is equal to everything until your maximum is -5. So everything less than -5, right? So you can say, you can write it with interval notation negative infinity. So you never include infinity because it's never going to end. So you can't really have a finite answer. Or you can write a set builder notation with when for all y values, if y would be less than equal to -5. Okay, so this is your other half of your solution. So when we're talking about the key features of quadratic function, we are going to talk about the vertex, axis of symmetry, minimum and maximum, where the graph opens towards domain and range. Okay. All right, so that was example 2, and try 2 will continue with the next example in the next video. Thanks for watching. See you later.